look at the blockchain technology, particularly how it differs from a traditional model of computing. So if you compare with the traditional model, it is much more easier to understand. So blockchain technology, it's a database. A blockchain is a database transaction that is updated across many computers in a network using distributed ledger technology. The point to note here is a database transaction that is updated across many computers. So in case of a traditional database, just a single database on which multiple client can access, client in the sense through the browser you access it, and the transaction get into the database, single database. Whereas in a blockchain, this database is across many computers in the network, and that uses the distributed ledger technology. So every time a new set of transaction is added, it's called a block, hence the name the blockchain. Most blockchains are public. Example is the cryptocurrency. You can add data, not remove it. If someone wanted to alter information or cheat the system, they need to do it with majority of the computers. That is not at all possible. So even if there are changes, that is added as a transaction. So here, I mean, a block, ledger, distribution, transaction, confirmation, proof of work, and the result. So the point to remember is it's a database transaction, but it happens across many computers. Whereas that is not how it works in a traditional model. In fact, blockchain is more than a technology. It is usually contains financial transactions. It is replicated, the same point, is replicated across number of systems in almost real time. So I mean, what you need to understand is in a database there is a transaction which gets committed. Similarly, here it is called mining, and that happens when the transaction is agreed upon all the nodes in the network of blockchain. So uses cryptography, digital signature to provide identity, authenticity, and enforce read-write access. Can be written by everyone, that is only in public blockchain. But in case of a private blockchain, only certain participants can do it. Can be read by participants, often by a wider audience. So this is a blockchain, different blocks, and it has a hash is something like a address. So each block has an address, and they are linked together. Has a mechanism to make it hard to change historical record, or at least make it easy to detect someone is trying to do. So I mean, because if there is a change in one block, or in case of the one node, the other node also the change needs to be replicated. If it doesn't happen, it will not get accepted across the blockchain network. So that way, any changes has to be across all the nodes of blockchain. So a centralized database essentially has single point. This is a centralized database. This is a normal traditional model in which multiple client can access the centralized ledger or centralized database. One single database, so multiple people access it. So that is where once the transaction is committed into the database, the others will also see the same transaction, provided they have the access to the database. Whereas in a distributed database, this is a blockchain that exists across several locations or among multiple participants, decentralized to eliminate the need of central authority or intermediary to process, validate, authenticate transaction. So in case of centralized, there is someone who owns it. In case of from a technical viewpoint, it is a database administrator. Then you might have an application owner. Then there is another umbrella as a corporate or company, and they have statutory requirement which needs to be met, because statutory requirement is provided by the government. So there are different umbrellas. Enforced set of rules are adhered to, but in case of a distributed ledger, all these are not there. So that's where it is going to be challenging as well with blockchain. But at the more, the technology is so very robust. So if there is a failure in one node, the other node will function as well, because they all have the replicated data with them. Records are only ever stored in the ledger when consensus has been reached by the parties involved. So that means in a kind of a database similar to a commit. So this needs to be committed across all nodes. Then only the record is kind of a validated record in case of a blockchain. And this is how it works. User initiates the transaction if it is a cryptocurrency. Between cryptocurrency exchange between the user initiates the transaction with digital signature. User broadcasts the transaction to the nodes, and one or more validating, because if it is across the nodes it is going to happen, but one node which has the identification will validate that node and validate that transaction and may accept it. And the nodes aggregate validate the transaction across the block. The nodes broadcast blocks to each other, and consensus protocol is used, and block reflecting true state is chained to the prior block. So this is an ideal example of a cryptocurrency. That is, when it happens, even if it is on one-to-one basis between the nodes, it is broadcast across all the nodes, and all the nodes has this transaction entered, so that there is no malpractice. So that is how a distributed, because each of the nodes have a copy of the transaction involved. So that's where it eliminates cheating or the failover. So distinction between the blockchain and the ledger. So this is again whatever discuss. I mean, this is where when you compare, if you are from an IT background, when you compare how a traditional model works with that the database ledger, it is much easier to understand. So assuming this is a traditional model of application where you have the database and then the server which runs the application, that is the second layer, and the third layer is the your browser. So your browser accesses the application, and the application in turn writes to the database. So this is how it happens. I mean, if you want to order some information, then from the database it is fetched to through the application layer, it is presented in the browser, and when you order, yes, through the application layer it gets into the database. This is a client server model. For a blockchain database, each participant maintains and calculates updates entry into the database. All nodes work together to ensure that they are coming in the same conclusion, providing inbuilt security for the network. So each of them will have the database. So unless all the database is synced, the transaction is not said to be complete as such. So that is an important difference between an ordinary database and a blockchain. So this distinction between the database and blockchain ledger. Databases have admin and central control. No one in the admin, particularly this blockchain, if it is a public blockchain. Only entities have right to access the database, of course. Either it can be technical folks like database administrator, or probably the application users. You need to have the user ID password. Anyone can access the blockchain in case of blockchains. Only entities entitled to read, write can do. Anyone with proof of work can write to a blockchain. Database are fast. This is an important point. That is where it becomes a challenge. Blockchain are slow because it needs to be authenticated across all the nodes where the data or the transaction resides. So naturally, blockchains are slow. No history of record and ownership of digital record. This I mean, maybe about a decade or two back, there could be no records of the ownership of a transaction, but these days, due to various regulations and act, even in an ordinary database, you are supposed, particularly any kind of a commercial application or any kind of a database which is for the corporate application, there needs to be a history of records, particularly all the ERP applications. It will not get the approval as long as there is a history of records. You just can't, any ERP system in the database, you can invalidate or you can pass a counter entry. You are not supposed to delete from the database records. This is as far as the traditional model is concerned. History of record and ownership of digital records are always available. So this is a kind of an, it's not, in the case of blockchain, it is by default you cannot delete it. By default you cannot delete it, but here of course you can do a kind of a malpractice is possible, but the rules and regulation, and more importantly the governance, the corporate structure, makes it difficult to even manipulate the transactions. So that's about database and blockchain. To make it in a simple statement, in a case of database you have a centralized database. In case of blockchain you have multiple nodes where these data are stored. So if you want to manipulate just one record, in one node at all, it will not get reflected across all nodes. So only if it gets replicated across all the nodes, then only and a consensus is reached, then only it is said to be final and there is a binding for it. And there is no centralized admin as far as blockchain, particularly the public blockchain. That is another point to keep in mind. I hope by this you have a good understanding as a difference between a blockchain ledger and a database, traditional database model. Thank you. Let's look at the challenges in blockchain adoption. Blockchain technology, you can though you can call it new, it's well known in the last maybe 5 to 7 years, but the adoption is comparatively slower when you compare with some technologies like cloud. So let's look at the reasons for why it is taking, if it is a superior technology, why the adoption has been slow in case of blockchain. Why it's not succeeding. Blockchain being a distributed technology, and if you look at the features, data immutability, meaning that you just can't, it prevents data being manipulated. It's decentralized because it's stored across multiple location, peer-to-peer communication. Features are good, but still the adaptability is much slower. So what are the probable reasons for that? What are the challenges blockchain has? So blockchain, we are trying to compare based on functionality, technology, cost and feasibility, and legality and statutory control. The first and foremost is given here, trying to apply blockchain to everything. That's highly not possible. We'll also look at the other challenges on the functionality, technology, cost and feasibility, and legality and statutory control. The first is functionality and technology challenges. So you need to compare, because in the same thing, the last 5 to 7 years, all the ERP application have the self-service application, particularly to use any kind of a P2P or O2C application, like in an ERP application like a distributor, or even for that matter a retailer can use self-service application in an ERP solution. So they can probably order the goods or get the service. So self-service applications are being developed, in particularly last 10 years, particularly with the ERP application, this has come in. So probably they can still not just the company alone or the corporate alone, but the complete ecosystem around the corporate can now use the self-service application. So that is what was missing earlier, but now that is available. Number two is technologies like rack, data guard, application failover, and again it's all available in a decade, just to 10 to 15 years. Prior to that, these were not available. Now these are available, making ERP application or any kind of application which uses the database much more robust. Database in the sense, the traditional model is much more robust, and more importantly the cloud technology as well. So it makes it much more robust when you compare with the blockchain technology. So all this like rack, data guard, application failover makes it impressive. Even the traditional or the legacy system is attractive as well. Blockchain, again, it's a complex technology that not only require expertise but also need business to integrate data with trusted sources. So it's a complex technology. It's not that easy that whereas racks with data guard application is tried and tested over across, there are multiple use cases or even the users who have been using all this technology in a traditional model. Cost, feasibility, and legality changes. Cost incurred in deploying blockchain in a business is huge as compared to traditional legacy model. So cost is very, very high. And if you compare with the traditional model, it is not so. And it is tried and tested as well. That is where the adoption is much slower in case of the blockchain. Expert resources. There are very few resources who has expert knowledge on blockchain. Lack of governance. And again, there are different levels of governance. Technical, if you look at it, there are database administrator, then you have the IT solution arc, and then the functional people, and then the company itself. On top of it, there is government, which has the statutory requirement as how a traditional database application needs to be. So there are multiple levels like the ISO standards, and there are so many other standards which enforce this governance. Public blockchain finally is a decentralized ledger. So in any kind of a business, there is always a clause for conflict. When conflict happen, what needs to be done if there is a kind of an arbitration, negotiation in business, which are all common. So in a traditional model, this is all well defined, but in case of a blockchain technology, this highly, particularly if it's a public blockchain, highly impossible. This we are even seeing in a Bitcoin. Almost most of the government across the globe are resisting the use of even the cryptocurrency or Bitcoin. So that again, if you look at it, Bitcoin uses the blockchain technology. So, but if you look at it, no one governs that. That becomes a real challenge in case of a blockchain application. So all this may be over the period of time as it evolves, the processing power comes cheaper. Maybe there could be better adaptability for blockchain application. So those are the challenges on blockchain having a blockchain application. Thank you. Stay tuned. In one of the earlier presentation, we saw about the industry 4.0, that is across the industry. We started with the mechanics or the mechanical based technology with industry 1.0, and then came the electrical system with 2.0, and electricals got evolved into electronics as industry 3.0, and then with computers, that is with software, it became 4.0. And now this is as far as the industry is concerned. Now we have this concept of internet or web. So it all started with mid 1990s, that is 1995 onwards, we have web. So how did the web or the internet evolve? That is what we are going to see in this presentation. The first one is web 1.0. Basically the first time when we started hearing about web, that is HTTP, that is HTTP protocol, when we had website. So it was basically creation of the web pages and contents. Web pages for a large group of reader, allowing to access information and content from the source. So website was used, that is from 1995. Mostly it is static web pages, just to disseminate information, just to know about maybe about different companies offerings, or maybe what the government offers to its people. It's just a one-way traffic. You can't do any kind of much interaction to the web. So it's basically to know what is a company offers. So that is web 1.0. So this was still about 1995 onwards, still about early 2000. That's what I would say, early 2000. And basically it was again client server technology with just one directional communication. Web 2.0, so Web 1.0 is read only. Web 2.0, it became a participative social web, particularly with all this social networking sites like Facebook and many other things, where you need to register to access it. And even the other business application like ERP application became accessed through the web application, where it is from client server, it slightly became a little more complex. I mean, instead of all these web pages started interacting with the database. So naturally, when you want to have the user ID stored, you need to have naturally the database. So that is where the Web 2.0 got evolved, and that is post 2000, around 2000 onwards, I would say. Though I mean, they call it from the reference point, they say, is the social web. Particularly the Facebook got more adaptability from 2005 onwards. So it contained dynamic content that responds to the user input. So depending upon what the user, even the ERP system, it is based on the responsibility. Whatever a clerical person will have a different responsibility for his work, whereas a manager might have a different responsibility. So the content is said to be dynamically changed, and it employs the API concept of API, where you can use the API to interact with the web. So that's but still it was the centralized, the information is centralized, and the people, though the users can access it across the globe, the data was from a central system, be it a web server or be it a database server. So it was all centralized. Now we are in Web 3.0, but this is users extensive use of blockchain technology. Still it is evolving. The reason is still there are challenges, and it requires investment. It is costlier as well, and there is not much of a control over it. It is based on the transaction, because the data is stored across multiple computers. The blockchain concept of blockchain. So nobody really owns it. It is just a single source of truth. It needs to happen on its own, and it may make use of machine learning, artificial intelligence. Though artificial intelligence, machine learning can be done with the Web 2.0, but Web 3.0 can also do that. But the important underlying point is this: Web 3.0 needs to be based on blockchain technologies. That is the basic criteria to get identified as Web 3.0. An emerging governance ideal within the blockchain and Web 3.0 community is the concept of distributed autonomous organization instead of central authority. Why there is no, by central authority, yes, think about it as just a web server and a database server. When you want to access that information, yes, you need to interact with the web server, and for if the data is going to be stored in the database server, the web server will access the database server to retrieve the proper information. So that is the centralized one. Whereas in the concept of blockchain, it is highly decentralized. The data is going to be stored across different nodes in the blockchain. So that is the underlying concept of Web 3.0. We'll get into more details as we progress. Thank you.